I'm Jimmy.
I'm Abby.
And I'm Maddie. We're at Colquitt's River in Victoria, BC.
The source of the Colquitt's River comes from Beaver Lake, as that's where it originates. It flows into Portage Inlet in Victoria Harbor.
Colquitt's River is a meandering river.
The Colquitt's River is a 9.5 kilometer stream from its headwaters in Beaver Lake to its outlet at Portage Inlet. It exists entirely within the boundaries of the district of Saanich, and its watershed drains an area of about 46 square kilometers. As a fluvial system, Colquitt's Creek is heavily influenced by urban development and heavily altered due to agricultural, residential, commercial, and industrial land use. It is a meandering stream, however its classification comes as a result of this urbanization alongside its relatively stable slope. A report from the Capital Regional District states that because the Colquitt's River watershed is contained within an urbanized area, water quality issues and other effects of impervious surface areas have important effects on the health of the system. Flows from impervious areas are flashy during rain events and contribute significant energy and potential erosion to stream channels, while paved areas and inaccessible floodplains are incapable of storing and releasing water in the dry season. Alongside the significant and growing effects of urbanization, the Colquitt's Creek is heavily influenced by the regional climate, like any fluvial system. Under the Köppen-Geiger climate classification, the Greater Victoria area is characterized as a CSB climate, a warm summer Mediterranean climate. This type of climate is characterized by having relatively mild temperature change, wet winters, and dry summers. In line with its climate categorization, we can see Victoria has higher participation in the winter months, with peaks of 150 millimeters, and low precipitation in summer months, with a range of 20 to 40 millimeters from May to August. The mean temperature from November to March ranges from 4 to 7 degrees, while summer months are around 14 to 17 degrees average. An interesting note on Victoria's climate is how mild it is. The temperature range is very small, especially compared to other parts of Canada. The shape of the discharge metric on our hydrograph for Colquitt's Creek shares similarities with the shape of the precipitation metric on our climograph. Discharge is high in winter months and comparatively low in the summer. Peak flow in meters cubed per second in winter is 3 to 4, while peak flow in summer sits around 0.1 to 0.3.
The topography of Colquitt's River is relatively flat and is located in a fairly urbanized area. From its headwaters at Elk/Beaver Lake, the river is in a forested area, and as we follow it towards Portage Inlet, it enters into a more urbanized region. The Colquitt's Trail is a well-used trail that follows along the Colquitt's River, which starts along Interurban Road and ends at its headwaters. Along the trail, there are a number of artificial features such as concrete stepping stones that allow for people to stand over top of the river. At the river's highest gradient, the elevation is about 58 meters, and as we follow the river towards its mouth, the elevation gradually decreases. Since Colquitt's River does not have a high gradient, this causes the river to meander.
The Colquitt's Creek and Colquitt's Creek Trail is a public area located in the Saanich area. There's a small parking lot located off of Interurban Road, south of Interurban and Mackenzie Avenue intersection. The creek runs mostly perpendicular to Interurban Road until it flows out into Portage Inlet in the View Royal area. The specific site we chose to observe was a small section of the Colquitt's Creek Trail located between Interurban Road and Rollston Crescent.
In the area of the creek we observed eddies were a prominent feature. An eddy is an area of a river where an obstacle blocks the flow of water and creates a spiraling current behind or around it. Usually an eddy will reverse the direction of flow in the river and cause the water to flow slightly upstream. Obstacles such as trees, rocks, or small islands will cause the flow of water to split into two directions. The area behind the obstacle has no velocity and has a neutral current, so the two streams quickly flow around and into it, creating an eddy. They also form around river meanders, usually alongside the point bar. When flowing around the corner of a river, the flow pushes into the bank where the river is neutral. The water then flows in a spiral, eroding the inside of the corner. Over time, this erosion continues and more water flows around, continuing to create space for the eddy. At the Colquitt's River, we observed features such as fallen trees and rocks that created eddies.
The second feature we observed at Colquitt's River was a meander. In this image at Colquitt's River, you can see how the river curves around this rock formation and how the inner bend of the river has eroded parts of the rock and has resulted in an undercut. Rivers may meander on low-gradient, broad areas which allow for a channel to bend, curve, or loop. Meanders occur when the maximum velocity of the stream shifts into an outside bend called the cut bank. This is where erosion occurs. Then sediments are transported within the river. The reduced velocity along the inner bends of the river, which are called point bars, cause the sediments to be deposited along the inner bends of the stream channel. The reason why streams tend to meander in low-gradient areas is because when the stream channel bends and curves, the stream's energy is expended and is used uniformly along the river.
The Colquitt's River has a large undercut feature just before the river intersects with Roy Road. Undercuts are banks that hang over the stream. In some cases, like the Colquitt's River, the energy from the river can erode the river banks to create undercuts. Undercuts are created at points of the river where the water is most forceful, like the outside of bends. Because of its location on the river, undercuts are very dangerous. Undercuts are located where the river is moving the fastest, and if you were to get trapped underneath one, the current would make it extremely difficult to get out.
To briefly link topography and stream discharge to the three features discussed at the Colquitt's River, eddies are formed due to the presence of rock formations along the river which may have eroded as meanders were formed, or due to rockfall, as well as branches falling into the river. In terms of the meandering of the Colquitt's River, the topography has a large influence on this feature, as the flat topography of the area around the Colquitt's River meanders, since its gradient is so low. The result of the meandering is a decrease in stream discharge, since the velocity of the water is also decreased.
In conclusion, we found that the Colquitt's River had many features that allowed us to measure the characteristics of how the river flows and at which speeds. The three main features we examined on the Colquitt's River were eddies, meanders, and undercuts. We found that fallen trees and large rocks along the river formed eddies where the river would flow around the obstacles. Secondly, we found that the Colquitt's River was meandering because it is located on a low gradient area. And lastly, we found that undercuts were a feature in the Colquitt's River that was linked to the fact that it was meandering. The energy of the river that flows along the meanders and riverbanks had formed undercuts. Our group collectively found that it was easier to apply these features to our learning in lecture and lab after seeing them firsthand. Being able to identify these features in a real-life situation gave us a better understanding of how they may look different between different fluvial systems.